All right, hello everyone. I hope everybody is still energized. Oh, thank you. Energized after a very long day of conference. Our talk will be about a limitation in Prometheus, actually. It's a precision issue, but I don't want to spoil the talk too much. I also wanted to say that this is really an honor to be here. I've been following PromCon for years, and this is the first time that I'm actually here, so thanks for having me. I am very nervous, as you might see, but that's why I'm actually talking a lot at the beginning, just to talk it off.
Are you less nervous now?
Not really.
We tried.
Yeah, but let's start with a short introduction.
Cool. Hello, my name is Bartłomiej Płotka. I work at Google. I specifically work on Google Managed Prometheus in Google Cloud. I also wrote a book called Efficient Go. I'm active in the CNCF. I maintain Prometheus. I co-founded Thanos. And also, I started recently a podcast called Optimize All the Things. It's about optimizations to your life, infrastructure, work, everything. Yeah.
It's a little bit hard to compete against that. Oh, nice, somebody got it. Yeah, I'm just Arthur. Seriously, I'm a DevOps engineer at Coralogics. I'm recently become a maintainer of Prometheus Operator. I used to be an SRE at Gitpod, and back in 2020, I was a mentee for KubeVirt. And right now, I'm a mentee for Prometheus under the Google Summer of Code program. And actually, what we are going to talk about is what we've been doing in this mentorship.
Amazing. I wanted to make a joke that I didn't get the Barpy joke as you, but you get it, so good job. Nevertheless, we are here today, and we're super excited to be on PromCon, our favorite conference, to discuss quite old counter limitation. And no, it's not about ability to decrease counter values. That's not limitation. That's a feature. But
yeah,
let me start with some short, quick refresher about counters. Hopefully you know that, but it's probably the first thing that somebody learns when they came into Prometheus, how counters works. But essentially, counter type in Prometheus represents a cumulative count of something, for example, error count, right? As we can see on the graph, for example, you can see the row counter value here, which represents a total number of errors that occurred on some server. The counter values should be always monotonically increasing. That's very important. Thanks of that property, whenever it decreases, we are sure that the counter was reset. For example, when the application restarts. However, the main value of the counter is not from its absolute values, right? Prometheus users actually rarely checks absolute values. What's really important is most likely the relative value of the counter, thanks to functions like rate, irate, or increase. For example, on the right, we can see a error rate over 1 minute that gives us a per second error increases. What's additionally nice about the rate functions is that they adjust for resets, so you don't need to worry about those things. And all of those properties, together with those rate functions, give us a really nice resilience for our production monitoring, right? This is one of the main reasons why Prometheus can be so cheap and reliable compared to maybe some other pure push-based solutions. Prometheus can miss some scrapes, sure. In many cases, it can still calculate a quite accurate representation of rate for our alerting and debugging needs, right? So that's why this quote from Brian Brazel, which was like 2017, is still very relevant. But the key aspect in that statement is a little bit cryptic, this average word, right? For some time, there appeared an opportunity to bring this average to the higher number and to have counters a little bit more accurate. But first, let's learn about this problem from the little story.
So, once upon a time, there was a rabbit and a turtle. And yes, this is a true story, believe us. The rabbit and the turtle were training for this legendary race. It's so legendary that there's actually history books about this tale nowadays. So actually, Bartek and I were very lucky. We were actually there. We saw everything. We were actually consultants to their coach.
Yeah, very lucrative job. I can recommend.
Yeah, their coach, the coach was training both of them, so he wanted to make sure that the turtle and the rabbit would run 30 meters every single day. He even set up alerts just to make sure that they were training. How the experiment works is, oh, sorry, I forgot a very important thing. The coach was using Prometheus, of course.
Of course, right?
He was using Prometheus to monitor the training. The Prometheus was scraping the app that was exposing data about the race every 10 seconds. And Prometheus would only be able to see the data if the animal crosses the start line. If the animal didn't cross, then Prometheus has no idea that the animal even exists. So yeah, both of them went to the racetrack. Camera person, I'm going to make you work. So both of them went to the racetrack, and we all know the turtle is a very hardworking animal, and immediately started his training. Bartek, do the thing.
Ready, set, go.
Yeah, the turtle was not very fast. So the rabbit saw the thing, how the turtle was super slow, and just thought, what a clown. I'm just going to take a nap, and I'll start when I feel like it. So the rabbit, and meanwhile, Prometheus made the first scrape. Turtle was already 10 meters away. So the turtle crossed the start line. Prometheus knows the turtle exists. The rabbit was competitive even in his sleep, and after only 10 seconds, it already has woken up, saw the turtle in the 20 meters mark, Prometheus scraped. But the rabbit noticed how the rabbit is not on the start line yet, so Prometheus has no idea that the rabbit even exists. But yeah, when the rabbit saw the turtle in the 20 meters mark, he immediately started to sprint. And the third measurement, Prometheus scraped, and both the turtle and the rabbit were in the 30 meters mark, finish line. Okay, sorry, I'm breathing hard now. So Bartek and I were there, as we mentioned, and we saw everything. But all that the coach had was what he could query from Prometheus. So the coach showed us his Prometheus instance, and the data looked super weird. Like, the turtle starts 10 meters, okay, it's kind of acceptable, but the rabbit started at the 30 meters mark. Like, how could he finish the race, the training, if he's already at the 30 meters mark? The rate function, like if we're rating over the travel distance, what we are showing is actually the speed. And how could he finish this training if the speed is 0? It doesn't make any sense. So, as we mentioned, the coach had alerts to catch lazy students, and every single day he would get alerted about the rabbit who finished his training with speed equals to 0.
Yeah, we want to help the rabbit, of course, right? To show that they actually made the training. So the issue that Arthur explained is not that rare, right? It is a kind of very common thing, and the common kind of pattern information that would be useful in those cases is if the counter that we see, the counter value, the first sample that we see and Prometheus scraped, is it a new created counter that just was created, or it is an old counter that we just didn't see what happened before, so we cannot assume anything. And you can see that in this example. So for example, here we see the number of counts again, but with some gaps. Like in a real production system, we might have some gaps, right? And gaps may be because the service discovery were misconfigured, or some hiccup, or just delay, or network blip, or Prometheus just restarting because you are upgrading a version. Unfortunately, this is where we seem to be, like failing this average, below average correctness of Prometheus from the Brian code, because Prometheus cannot really tell much from this situation. For example, first few samples, we cannot tell really if this 200 value is for a new counter, so just recently increased, like literally before, or it is an old metric and this increase happened like 2 days ago. What's even worse, in a second batch of samples, Prometheus can tell if there was a metric reset between those two streams, And if there was a reset, then we should kind of accumulate for, we should represent a large increase. Maybe there was no reset, which would be only increase of 10. So that's really important, right? In other words, we cannot tell if this situation represents, this situation, or this, or any other kind of unlimited options that might have happened. And the result is kind of like tragic because we don't really have, we would not alert on maybe important information about, higher error rate, because Prometheus stays on the safe side and essentially decides that the rate is 0. So this is really important. And there are 2 known mitigations. You might know some of them. So let's go through that. First of all is the PromQL magic. Can you raise your hand if you understand quickly what's happening here? Go, 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 go. 2 more seconds. Whoa, yeah, 2 people, 3 people, nice. So this is actually kind of like relatively straightforward. Essentially what it kind of tries to do is like you have a rate, you kind of care about your rate, but then you kind of check the edge cases using aptness metric. Hey, what was happening with my scrape situation just before, like 1 minute before? So you could assume some kind of existence of this counter being there or not. So, but it's very complex, prone to errors, very hard to read. So what we rather recommend usually is to initialize your counters. You probably heard about that. I think we were talking with Kemal about this like, I don't know, 5 years ago. But generally, how you do that, for example, in Golang, you just initialize your dynamic labels with known values. So for example, for HTTP requests, we know that most likely we'll have some successes and some not found errors. So we can populate those and put 0. So we'll be exposing a new metric with those with the 0 value for 200 and 414. But it's not applicable to try to predict all the labels or even pre-populate all the status codes you would have, because that would be hundreds of or thousands new metrics that you might never use. So it's just a waste. And also, sometimes you cannot predict the values, right? So, so this solution is not very reliable. Fortunately, the created timestamp kind of idea existed for a long time, but it got more popular nowadays with this in the CNCF observability. First time I personally saw this solution, this kind of like improvement, is when I joined Google this year. And because such technique, such kind of thing is required when you ingest the data into our monitoring system called Monarch, right, at Google. Because kind of Monarch really cared about accuracy of those counters, so they build that in and actually require on every ingestion. So created timestamp, semantics, is essentially a piece of create timestamp is essentially a piece of metadata that you associate with few samples, and it tells you for sure that the counter started, the counter value 0 or reset was exactly at this precise moment. Essentially, in this case, visible on the screen, is super important information, right? Because the absolute count, if we just try to adjust for the reset for those samples would be 15 in Prometheus, right? But the truth is, thanks to created timestamp, we see that actually we missed some scrape, and between 10 and 15 there was a reset. So the actual absolute kind of count value would be 25, and that's kind of very, very important.
Okay, so in the Prometheus ecosystem, at least, the first appearance was made by OpenMetrics. OpenMetrics says that every counter, summary, and histogram should optionally add a timestamp that represents when the counter, summary, or histogram is first initialized. It is mentioned in their specification that the intention is to help ingester to discern between new metrics and long-running metrics that Prometheus just happens to see for the first time. A few years later, OpenTelemetry also came up with the same idea. It just changed the name slightly to StarTime Unix Nano. So we all know the semantics now. So what can we do to get created timestamps into Prometheus? The first step is instrumentation. Let's talk how can Prometheus scrape created timestamps from an instrumented app. Candidate is OpenMetrics text. Prometheus already accepts OpenMetrics text, and OpenMetrics text also has created timestamp. So why not? So the problem is that it's a little bit complicated to accept open metrics in Prometheus. The way Prometheus interprets the text is, as you can see, this is kind of two series. One for full total. Yes, one for full total, and a second metric for full created. There's also the problem that there's nothing stopping a user to create a gauge called full created as well. So the name of the created timestamp of the counter clashes with the name of the gauge. We could improve Prometheus to somehow parse that, and like we need to maintain a complex code to make the created timestamp as a self-contained thing. So if you're just ingesting as metrics, an instrumented app that has mostly counters would potentially double the amount of resources that Prometheus needs to have just to ingest the created timestamps. And finally, other protocols do not treat created timestamps as a other time series. It is a self-contained thing. So instead, we decided to use the recently resurrected Prometheus protobuf, mostly because Prometheus protobuf already supports native histograms. Thank you, Björn. So as we can see, and on the left is OpenMetrics protobuf. OpenMetrics protobuf already has created timestamps, and in the right is OpenMetrics protobuf, and the left is Prometheus protobuf. We are doing the same thing. We are basically just adding optional created timestamp to counters, summaries, and histograms. And during the design process, we came up with two ideas for the storage implementation. We already implemented one. And this strategy is what we call zero injection. If the created timestamp of the time series being exposed is higher than the timestamp, sorry, English is a little bit hard. It's higher than the timestamp of the previously ingested sample. Instead of ingesting only one sample, we ingest two. It's a little bit hard to see, but this one and that one are green. The green ones is what is injected 0. The timestamp of the sample is equal to the created timestamp that is exposed by the app. And after we inject the 0 sample, we ingest the usual time series exposed by the app. And it has advantages. This is a fairly simple implementation. We don't need to change a single line of code in the rate function, and we already see amazing results. But also comes with a few downsides. We cannot ingest created timestamps out of the head hinge. So we are a little bit limited about how old the application can be, so we can inject the 0 sample. We already have a few ideas to improve that, but they are not implemented yet. OK, so let's go back to the training. We kindly asked the coach to upgrade the Prometheus to the version that we implemented. And in the left, we see the new results. Like the new results, we can see that both the turtle and the rabbit starts at 0 and not in 10 and 30 like before. We also see the differences on the rate without changing a single line of code. The rabbit is not teleporting to the finish line. It's just super quick, and Prometheus could not see that.
Yeah, but thanks of the...
Oh, sorry.
It's fine, should be fine now. Yeah, but thanks of the created timestamp, we can kind of know much better what was happening, right? And this is the same kind of for our error counts. As you remember, now exactly just the same situation, if we just apply created timestamp, it would look like this. So not only rate just works, it's also visualization is much more understandable, right? Just you need to be careful because perhaps if we accept this change, you might have some zeros, some samples that are not scraped samples, they are created timestamp samples. So you have to be a little bit, just be aware of this. But generally, it should help, that implementation should help enormously. Because, again, with this more, more information in our error count, we can kind of finally see the increases, and they were kind of quite large, so we would miss an, error spike. Okay, to sum up, how you can use it. So generally, it's in progress. I mean, the code is there, it's being tested, but we have to accept it. We have to merge it. We'll be talking about that on Saturday, the summit as well. But essentially, what will happen is that you can upgrade. If you use Golang, you can just upgrade client Golang. And thanks to Arthur release yesterday, you can just upgrade it, and it will have created timestamp kind of emitted from your instrumentation. Then it's just as easy as once we merge, upgrade Prometheus, and there is a new configuration change, most likely, for scrape config, for scrape job config, where you can choose what protocol you would use to scrape. And this is where we would probably go for Prometheus protobuf exposition format as a recommended kind of first choice. And you will be able to configure that. Maybe we can change that, as a default option in 3.0. I don't know. Let's see. But this is something you have to be careful. Now, there is call for action as well. We would love other instrumentation libraries to also emit created timestamp, maybe use Prometheus exposition format. And also, we want contributors to kind of like get other protocols to be useful with created timestamp. And that's totally possible, just amount of work to be added. So even OpenMetric Proto and OpenMetric Text can be kind of like supported. Like Prometheus can be able to kind of parse the created timestamp from them properly. And before we finish, a few words about open source mentorship, right? I can tell you from my perspective, like mentoring is amazing. We should do it much more often, and especially in the CNCF, there are lots of opportunities because CNCF participates in Google Summer of Code or Linux Foundation, and it's for everyone. So, Arthur, was it useful for you?
Yeah, of course. As a wise man once said, you are an average of the people you are surrounded with. Naruto Uzumaki. Sorry, I'm spoiling things. So yeah, of course. 3 years ago, like just some context, 3 years ago, I didn't even know Go syntax. Like I was complete beginner. And now 3 years later, I'm a Prometheus operator maintainer. I was client Golang maintainer for 1 day, but just details. Yeah, it's very clear to me that I've improved a lot with hard skills, soft skills. So I want to thank everybody in the community who spent time to help me. It's really, really important.
Yes, so hopefully we kind of, I don't know, you can jump in as well. So the point is, you were a massive help to us, Arthur, as well. So it's kind of like beneficial to both mentee and mentors. We get to finish features, we get to, empower new people in open source and really in programming as well, and potentially have new maintainers, right? And if you are interested to be mentored or mentor others, like you can go to this website, you can ask us, we can guide you. But my point is, like we can make mentorship real. So even if you are just contributor to Prometheus, not maintainer, you can mentor others with the Prometheus, for example, team member. And you can if there is a feature that will be accepted, we can work together and mentor together, right? For example, I co-mentored with 2 other people from Google, and outside kind of a contributor to Prometheus.
They're not maintainers. Right?
Yeah, and they are not maintainers, and they were totally helpful. So you can help as well. Please help us mentor new people in the community and make things empower new people in this space. So that's it from us. You can reach out on those Twitter handles or X handles. We want to thank you to our commentors, Max and Daniel from my Google team, who helped mentor Arthur. And thanks to those companies, Google, CoreLogic, CNCF, so we can mentor in the open. Thank you.
Thank you.
Thank you so much. Do people have questions? You should know the drill by now.
Understandable topic, I guess.
Oh, all the way up, Kemal.
Oh no, it's just dark there, yeah.
There's your workout.
Hi, thank you for the talk. So do I understand this correctly that the fix you mentioned is merged in Prometheus now, but not released in a version yet?
No, no. We have a working implementation.
In the pull request.
In the pull request, tests are still not there, but will be. Once we get merged, then yeah. But it's not merged.
Okay, thank you.
Hi. Have you done any benchmarks to see whether the response size is going to increase drastically when we add this additional created timestamp to each time series, or each sample, basically? That's
Response size of what?
Of basically the client exporting metrics. So the protobuf size, essentially.
Benchmark on the client side. I don't think I've done anything.
No, but it's another field in protobuf, so it should be fine. And also, like every other protocol do that, so it's also like they kind of accepted this penalty. But yeah, you're right. We will do benchmarks to kind of show the difference, but it should be like negligible.
Yeah,
it's only one integer, really.
While people are thinking if they want to ask a question,
Just one more, maybe last one. Yeah.
We are going to prepare for lightning talks. So Augustine and Raphael can already come down, and maybe Hayu Son and Daniel can also start showing up.
Yeah, thank you. I'm not sure if I understand it correctly, but will this force a change into the TSDB format, and will other tools like, for example, Thanos Sidecar can be able to use this?
Yeah, no. Like since we are appending a sample to the TSB, there's no changes to the TSB. It just works.
That's the beauty of this solution, yeah?
Yeah, perfect.
Okay, thank you, everyone.